And in this session, I will talk about profiling. Profiling as measuring your code to find out where it is slow, where it takes too much memory, and so on and so on. So let's start with basics. What is profiling? When should you use it? How do you use it? This is a scientific definition, a form of dynamic analysis. To put it in layman's word, you want to measure how fast your program works, how fast different parts of your program works, what is memory usage at some parts, and what parts are called, what parts are not called, and so on and so on. I will mostly focus on speed issues today. I will mention others in passing. Donald Cute had a nice quote many years ago, maybe even before I was born. Don't optimize if you don't know what your program is doing. Typical mistake with new programmers is they say, oh, it's definitely too slow up in this function, let's optimize it. And then it turns out that this function is called once and takes 2/10 of the second, and who cares if it's optimized or not. Measure first, optimize later. What I just said. So what are the tools that will help you? One way is to add some code to your program that will tell you how long some operation has taken. This is also very helpful if you are trying to locate memory issues. For example, if you have a program that doesn't release memory, then it's very simple. You start with it with any of new Delphies, and FastMM will tell you where the leak is, especially if you use the full FastMM version from the SourceForge and enable the appropriate detection switches. But if you're just keeping a list somewhere inside your program and you do release anything on exit, then there's basically no tool that will tell you your memory is being eaten at this point and is used in this list. Aqtime, which I will mention later, has some memory profiling built in, but most of the time it's logging in your code. You try to think about what the critical parts could be, and then you add some code before and after to check out how much memory is used and so on. And this can also be used for timing, to log timing, for execution timing, and so on. Then there are profilers. Profilers are tools that are specially designed for profiling, as the name says. And we have different kinds of profilers. First, there are statistical profilers. They let your program run, and they check every now and then. In fact, they check very often where your program is at the specific moment. Where is the instruction pointer? Which part of the code is being executed at this moment? And then after 10 seconds, 20 seconds, half a day, who knows, you can collect this data back and see in this 100 million times the code was checked, 95% of the time it was in this method. So you can fairly safely say that, statistically speaking, this is the most used method, and you go there and optimize it. Then there are instrumenting profilers. They will add specific instructions into your code, and these instructions will measure the time spent inside methods. And there are two kinds. Source instrumenting profilers are profilers that change your source code. And then you have to recompile and profiler will generate the data, or basically program itself will generate the data when it's run, and then you use the same profiler to clean up the code. This was quite an unsafe operation 10 years ago. You should make sure that you always had your backup and so on. But now when everybody is using source control system, I hope that you do. If something is messed up, you just pull the last version out of the source control. And we'll be seeing examples of all those three kinds of profilers today. Then there are event-based profilers. In some programming languages, the execution infrastructure allows you to add some hooks inside it. For example, Java runtime has this option. It can tell you, now I'm starting this method, now this method has completed. And you can collect your data there. This is sadly not available in Delphie, but it's basically a method of, basically application of instrumenting, but this instrumentation is already done before in the runtime environment. And there are hypervisor profilers, which are also not available for Delphie yet. The idea is here is if you have a virtual machine knows exactly how long your code took where, because it executed all those instructions in the virtual machine. So it can tell you anything. What's also, for instance, available with hypervisor-based debugging, and which we can't get yet in Delphie, is option of reversing your program. For example, you come to a crash, and you tell the hypervisor, please rewind these 10,000 instructions back, and then single step to the code so I can see exactly what happened before the program crash. If we could get this into Delphie. So spent a little speaking about tools. Aqtime was one of the first very professional profilers for Delphie, written initially by a guy who developed memproof, if maybe you remember that tool. It was a tool that helped to find memory leaks before we had FastMM. And is available for practically everything. It integrates directly into RAD-Studio or Delphie. It works with 64-bit code. It's bloody expensive. But the good thing is that you get it in XE and XE2, not in the starter, but I think in all other editions. It definitely is there in the professional. Today I will be running XE for demos, because my XE2 installation on this notebook is a trial version only, and the trial doesn't install Aqtime. So if you want to test it, you need to have a full Delphie install. And Aqtime is code instrumenting profiler. It will take your exe and it will insert instructions directly into your code, into compiled code, and those instructions will measure time and everything. It can measure allocations, what was executed, what was not executed, which libraries were loaded, and so on and so on and so on. Sadly, only this one works in the free edition that comes with Delphie. So you can only measure code execution times. For all others, you have to pay. Then Pro Delphie. Helmut Adolf, German, wrote it long, long ago. It's still being actively developed. It's now version 15 or 16 or something. From the beginning, its major point was that it's extremely accurate, much more than other profilers. So it can use it to measure execution times of short pieces of code. Because what's the problem with the profilers is that they modify your code. And by doing that, they change the behavior. And by so automatically your code becomes larger. If it's larger, it doesn't fit the processor cache so easily as before. So it automatically runs slower because it's larger. Then there are calls added to measure times, and those calls are never completely accurate. So if you wrap a very short, if you measure timing in very, very short function, for example, a function that only assigns a result to some constant, you can easily get a result that is much too large, much larger than reality, because all the measuring overhead and everything will inflate this true execution time. And Helmut managed to minimize this effect, so his profiling is really, really good. And it's also very weird, you'll see. It doesn't conform to any application standards as we are used to. It looks like Visual Basic application from 1980 or something like that. It's not
memory usage?
No, this one also measures timing, only measures timing, no memory usage. It's not very expensive, but what's interesting, there's separate ANSI and separate Unicode version, and there's also separate 32-bit and separate 64-bit versions. So if you have to measure all those combinations, you need 4 profilers. In reality, you have to buy 4 profilers. There's free version, which is limited to 20 procedures, so you can test it out to see if it suits your needs or not. Your program can have more than 20 procedures, but it will only measure time for 20 procedures. Then there's sampling profiler written by Eric. I forgot his second name. It's here, delphietools.info. Works from Delphie 5 and above. Although officially it doesn't support XE2, it works with XE2. I tested it. This one is a sampling profiler. So it leaves your program untouched, just samples where it is at specified points in time. What is good with this profiler is it will not give you the complete picture of the program execution. The code instrumenting and source instrumenting profilers, did I say the Pro Delphie is a source instrumenting profiler. They also know which method called which other method. So you can get from them a code execution graph. You can see which method was called by which method and which method was called then, and so on and so on. Statistical sampling profiler doesn't have this information because it just measures where the program is. But it also doesn't modify your program, so your program runs at the full speed. And these measurements are really, really meaningful. It will also show you information below the method level. Pro Delphie works at method level, while Aqtime will profile your code at line level if you buy the full version. The free version only works at method level. So you can get here execution times for each line in your program, not just each method. And it will tell you which, if your code is spending lots of time by calling system calls, spends lots of time in the kernel, not in your code. And it also provides a real-time monitor. This option builds in a simple web server, so you can connect to the remote machine over HTTP and check what the program is doing. So if your web service suddenly becomes very slow, you can connect over the web and see where it is spending its time. And it's free, maybe the best part. Then there's a do-it-yourself solution. Add the code to your program. Basically, you can call get tick count, which is not very accurate because on most systems, although get tick count returns a value which is accurate to 1 millisecond. It will advance in big skips, not in 1 millisecond, but in, I don't know, few tenths of milliseconds. It will just increment every 40 milliseconds by 40 milliseconds, for example. So it's not very, very useful. On newer Windows, that is Vista and newer, the now function will get you a millisecond resolution. It's best to use multimedia function time, which is on most systems works with millisecond resolution. And if you need something even better, there's query performance counter, which is Windows API function, and this works below 1 millisecond because it queries directly the CPU. Since, I don't know, 486 or Pentium, every CPU has internal counter which increments every instruction. So you can always ask the processor how time has passed since you were turned on. And this is used here. This instruction is called read time stamp clock or something like that, RDTSC. And you should never use it directly. You can only call this assembler function if you are sure that your code will always execute on the same CPU. Because if you have multiple CPUs in the system, their clocks are not synchronized. So if you read start time from one CPU and then Windows move your thread to another CPU, you will get result that doesn't mean anything. Query performance counter knows about kernel, knows where it moved your thread, and so it can fix this. So you should always call this one. Why profiling? Usually you profile your program because, okay, it uses too much memory or it's too slow. And after you detect the critical points in your profile, in your program, you have to fix them somehow. And there are basically two approaches. Change your algorithm or optimize your code so it performs the same but faster. Usually, it's much better to change your algorithm. And changing your algorithm can be something very basically, like changing it to not allocate memory in many small chunks, but use one big buffer and separate it. Or change your algorithm so not to concatenate strings letter by letter, because, again, each string concatenation is memory allocation. Or, as we will see in the demo, change your graphical user interface and use different Windows controls, maybe. Faster code means optimization, typically writing the code in assembler, or if it was already in assembler, writing it in a better assembler, like using multimedia or SSC instructions for data processing. This should be only used by professionals. I don't do this. So if your algorithm is perfect and your code is still not good enough, you can find an assembler guru to write the same code for you in optimized assembler. You can easily get a 10 times increase in speed on such stuff, but you will never be able to maintain the code. So choose wisely. Well, this approach is very popular in image processing because in image processing there is not much space for algorithm improvement. You have to process all pixels in some way, and this can really be improved with appropriate assembler code. But